Okay, this video is going to fill out the top flap of section 7 in your Unit 11 flipbook. Class, the top flap, not the bottom flap. So look at the top flap and write this essential question. How do I change a standard form quadratic equation to vertex form by completing the square? Now we have done this before in a previous unit on quadratics. And now we're going to review this because I want you to see the connection between this procedure and a procedure that we'll use to complete the square for circles. So how do I change a standard form quadratic equation to vertex form by completing the square? Well, let's go through the process. And I've given you lines, class, that describe above this line what the actual step is. So step number 1, put the terms in proper order. We can take a look and see right now that these terms are not in proper order. In order to complete the square, we want to make sure y is on one side and then our squared term is next, which is our a term. Our b term, or the value with the variable that doesn't have an exponent, is next. That's our b term. And then our c term is last. So step number 1, put it in proper order. Step number 2, move the constant to the left side. Here is our constant, which is -3. We're going to move that to the other side. When we add 3 to both sides, the sign is going to change to +3 when it moves to the left. And now we have moved the value of c, or the constant, to the left side. The next thing I want to do is make a little note, class. Identify b, because we're going to need the b value in the next 2 steps. Our b value is the coefficient that goes together with the non-squared x value. So the b value here is +2. Alright, next step is the actual complete the square step. And the way we do this is we're going to write out our equation, y plus 3 plus some number equals x squared plus 2x plus some number. This number is the special number that will allow us to complete the square, which means it will allow us to take this right side and turn it into a perfect square trinomial, which means we can factor it with 2 binomials that are identical. Alright, now how do we find this value that goes in that space? It is found with the equation b over 2 squared. So let's plug in our b value. b is 2. This is 2 over 2 squared, which is 2 over 2 is just 1. That's 1 squared, and that is equal to 1. So our number that's going to go in this blank is just 1. We have now actually completed the square. Now we have to do is just finish it up. The next step is simplify the left side, factor the right side. So let's simplify the left side. Y plus, looks like we got a 3 plus 1. So y plus, we can combine those terms together. Y plus 4 is equal to, on this side now we're going to factor, and because it's a perfect square trinomial, we're going to write x something quantity squared. This blank that we fill in comes from the equation b, or the expression b over 2. We know what b is. B was found to be 2. We found that in the 2 steps ago. So 2 over 2 is equal to +1. Notice, class, the value we use to complete the square will always be positive because we're squaring that number. But the value that we use to factor can be negative if b is negative. In this case, b is positive, so it's +1. We'll put +1. We have now factored the right side. And the last step is move this constant, this 4, back to the other side. So our final equation is y equals x plus 1 squared minus 4. When we subtract 4 from this side, we have to subtract 4 from this side, and we change the sign, we moved it over to the right. So now we have gone through the practice of how to factor a quadratic equation, how to complete the square of a standard form quadratic, and that actually changed it to vertex form. Last thing, let's remember that the whole point of this process was to find the vertex. We know the vertex is at h comma k. Our h value here is -1 because we flipped the sign. And our k value here is -4 because we keep the sign. So our vertex is at hk, which is -1, -4. Alright, let's do one more. Let's practice this. Next equation. Y equals x squared minus 6x minus 11. First step, put these terms in proper order. Well, it looks like they've done that for us. So I'm just going to rewrite it. Got the squared term first, the b term or the non-squared x second, and the constant third. Next step, move the constant to the left side. We're going to add 11 to both sides. We get y plus 11 equals x squared minus 6x. Next step, complete the square for x. In this step, we're going to rewrite our equation and make a nice blank. I'll always put positive because we know this value has to be positive. Equals x squared minus 6x plus some number. What is that number? That is found with b over 2 squared. Oh, we forgot to identify b. Take a look. In this case, b happens to be -6. So this is going to be -6 over 2 squared. -6 over 2 is -3 squared. When we square -3, it changes to +9. So our value to fill in the blank here is +9. Alright, next step. Let's simplify the left side and factor the right side. So simplifying the left side, we get y plus, we got 11 plus 9 is 20, is equal to x some number quantity squared. That number that allows us to factor the right side is found with the expression b over 2. In this case, b is negative now. This is -6 over 2, which is equal to -3. So the number needed to factor is -3. And the last step, let's move the constant back over to the right side. To subtract 20 from both sides, we have y equals x minus 3 quantity squared minus 20. And from here now we have vertex form. We know that the vertex is going to be at h comma k. So in this case, our h value is +3. Our k value is -20. And there's our vertex. So there is your refresher, a review on how to complete the square, starting with a standard form quadratic and ending with the vertex form, which tells us clearly what the vertex of the parabola is.